Hello, everyone. I'm Professor John Nguyen, and welcome to Chemistry. In this chapter's organic compounds, I would like to show you how to identify what type of organic compound we are talking about, functional group and the class name. And also, I would like you to show you how to name the simplest type, which is hydrocarbons. Okay. All right. We classify organic compound based on functional group. Meanings functional group mean structures, meaning you look for any special atoms like oxygens, nitrogens, anything other than carbon and hydrogens, uh, any special bonds like double bond, triple bond. We're not saying like carbon and hydrogens are not important. They are the backbone of any organic compounds. Okay, they have to be there, but in order to have a class, in order to have special functional group, we need atoms other than carbon and hydrogens. Okay, well, the first type is hydrocarbons. Hydrocarbons, we actually have four different kinds. Alkanes only contain carbon and hydrogens. Um, Only single bonds, no double bond. Okay, so and please keep in mind carbon has to have four bonds. So if you have one carbon, you need four hydrogen to be to bond it to that carbon. So four bonds. Okay. Now if you have a CH3, that has to be bonded to something, another carbon, for example, to make it four bonds. CH2, if you notice, is in the middle. So you only need two hydrogen because the carbon already bonded to the another carbon on the left and also a carbon on the right. Okay. We also have cyclo, which means the enclosed structure, like cyclopentane. This is cyclopentane right here. Okay. Cyclopentane, pentane mean five, and cyclo mean enclosed structure. Cyclohexane, that would be six. Okay, like a hexagon. And we also have alkyl group, which we're going to talk more later when we name organic compounds, like methyl. Notice that if it's CH3 bonded to something, we call that a methyl. It's a branch or a substituent. Excuse me. Okay, now ethyl is a branch with CH3 and CH2. Propyl is a branch with three carbon, CH3, CH2, CH2, that's bonded to something. Okay. Alkanes doesn't have any special functional group. Okay. And they're pretty unreactive. Just a couple reaction like combustion and halogenation we'll talk later. Okay. Now alkenes, as I mentioned earlier, alkene is has a special bond. There's no special atoms. That's just carbon and hydrogen, the basic, the foundations. Um, the special bond is a double bond. Okay. So you notice that a CH2, the carbon has already two hydrogens. So only need two more. And it can be two single or a double. Double count as two. So that's why it's double to another CH2. Okay. Notice right here, CH2 double, that make it four. But you notice that the middle carbon has only one hydrogen because on the left side, uh, it has a double, that's two. On the right side, it's bonded to a methyl, that's one, that make it three, plus a hydrogen, that make it four bonds. Okay, and that's the functional group. But our job here is not to name it or understand anything other than identifying the class name, which is alkene, okay, the class name of this functional group. Here's another example. Alkyne. How do you know it's an alkyne? You look for special bond, like I mentioned, triple bond. Every time you see a triple bond, it's an alkyne, okay? That's the name for this type of bond or functional group. Aromatics are very special, like 3 double bonds. Benzene is an example, C6H6. This is aromatic right here, and this one too, with 3 double bond alternating, double, single, double, single, double, single, okay? That's, and it has to be an hexagon aromatic. Of course, we have other form too. We can get real sophisticated aromatic compounds, but let's focus on that for today, okay? Okay, so those are the 3 functional groups we learned so far: alkene, alkynes, and aromatics. Okay, aromatic hydrocarbons. Sometimes we just call it aromatic. Okay, and that's an example right there. Okay, so identify functional group for the following compound. The first one, we see a double bond. That's an alkene. Second one, we see a triple. Okay, there's actually 4 in there. 1, 2, 3, 4 carbons. A triple, that's an alkyne. The C right there. And aromatic, that's a D. That's aromatic hydrocarbon for both of them. And the last one is just an alkanes. Alkanes. Okay, alkane is not really a functional group. Okay, because there's no special reaction going on. All right. Now, more functional group. We have about 11 different functional groups. Okay. So with oxygens, we have alcohols. Every time you see an organic molecules with OH, wherever it is on the molecules, it's alcohol. Okay. The name of the brand is hydroxy or hydroxyl, and the name of the functional group is alcohol. Ether, notice that's OH. Okay. Ether only oxygens. You don't have a hydrogens next to it. That's ether. You got a branch on the left and you got a branch on the right. A branch, when I talk about a branch, I mean anything with carbon, like methyl. Okay, that's ether. Aldehyde, for example, like diethyl ether, you see oxygens. Okay, that's a ethyl on the left, ethyl on the right, and that's why we put double, because there's the left and the right branches are the same. Dimethyl, methyl on the left, methyl on the right, the oxygens, and we can put parentheses times 2. Okay, now aldehyde ketone, you look for C double bond O. Okay, C double bond O with hydrogens, that's aldehyde. With no hydrogens, you notice it's a ketone. Okay, and we got an example here. CHO is also a good way to write aldehyde. And if you just write CO, that is ketone, because that's no hydrogens. Okay. Carboxylic acid is a combination of C double bond O and also OH. Okay, so that's why you see COOH. All right, you see that very popular, like acetic acid, COOH. So you gotta have 2 oxygens, double bond O and OH. Okay, and the hydrogens. Now, if you don't see the hydrogen, so it seems like with hydrogen or without, it's pretty cool, huh? That's different name for it. Okay. And that would be derivative, carboxylic acid derivative, running from ester, like no hydrogens. If it's COOH, that would be acid. But because it's another branch, instead of hydrogen, we call them ester. And that's another branch there, could be anything. Ethyl, methyl, okay, or benzene. Now, we also have other functional groups like acid chloride, amide, like with the nitrogens. Okay, so that's good to keep in mind. All right, we got some practice right here. And the aldehyde, because we see CH, C double bond OH. We don't see hydrogens. That's a CH3. That's a ketone. That's an acid chloride because it's got the chloride. That's an alcohol, and that's strictly a ketone. Okay. That's an ester because we don't see the hydrogen, but we see a branch. That's ester. That's an ether because we got a branch on the left, we got a branch on the right. That's ether. Now we got both double bond O and OH. That's carboxylic acid. And if you just have an OH, that's an alcohol. Okay, now finally we got a few more and we're good for functional group. Amine, any compound with nitrogens like NH2 or even NH or just N, okay? You got nitrogens, you got an amine. Now amine is a combination of double bond O and amine, okay? Which is a ketone and amine right next to each other. And finally, nitrile is just CN, okay? Take a look at this example. That's nitrogen, nothing else. It's an amine, A-M-I-N-E. Nitrogen again, even though that's a hydrogen, it's still an amine. Okay, different kind, but it's still an amine. Now this one is interesting. You got a ketone and you got the nitrogen. The only way this can be is an amide, like this one, A-M-I-D-E. Okay. And finally, CN, that's signature structure of a cyanide, okay, or nitrile, CN. The name is nitrile. All right, we got a few additional problems for practice and be able to identify the functional group and stick a name on it, okay? Like alcohol, put a name on it. Benzene, the name is aromatic. So you guys, one of you guys give it a try, and we have time on the next video. We'll go over them real quick, or you might ask me during the chat or Zoom, okay? Optional meeting. All right, thank you all, and see you on the next video soon on the same topic, Chapter 7, Part 2. Thank you.